Hello, everyone, and welcome to the follow-up video of today's in class. So, uh, let me share my screen and let's continue from where we left off. Okay. All right. So today we actually got started by building this waffle structure. Uh, I showed you a couple of techniques for creating the underlying surface because we need to have a solid object in order to get these uh, you know grid sections. So for that reason, we actually need to get to this stage where we have a flat surface, whichever might be. In your case, it could be a wall, it could be a ceiling, or it could be a you know floor, and the you know the contribution that you want to do. Like how do you want to extend this surface into another direction? Uh, and then we need to combine both of them, uh, essentially, or like join them together with the loft surface. So we got to this stage actually during the class. However, we had to leave uh, at that point where we need to actually start creating some contours to this. All right, so let's move on to completing uh, our goal, our initial goal. So here um, we have a essentially two methods. One is we need to we can either use Grasshopper's own uh, component called region slits, and this actually in some cases it might work. However, in our case, it actually generates some unpredictable uh, results. So for example, here in this instance, the slit directions are all, randomly distributed, and it might actually create problems during the fabrication process. So for example, this one over here, which consistently is like having a problem, it actually opens up, it doesn't open any slits in this direction, and in this direction, it actually creates wrong openings. Okay, so in order to alleviate this problem, we can actually do open the slits ourselves. So if you, for example, check over here, I have a cluster of components here that actually generates the slits to our, uh, you know, for our purposes. So they can actually match together in such a way. However, in order to obtain this, we need to like have an additional set of components that are arranged in such a way. It might seem complicated, although it's actually not very hard to, you know, get to. This process basically, helps you uh, get there much quicker than, say, you were to open these by hand. Okay, so um, the last part, again, this is optional. Like we actually don't even need this at this part because we're not using this portion over here, and this portion is actually all about making these 2D profiles into 3D solid objects. Okay, so what we do first is we are basically kind of like shifting them because the slit openings are like having these slight offsets because of the way the components work. So we are shifting it ever so slightly and then doing an extrusion. Okay. Now finally we're capping them to create solid surfaces. And then if you like, you can actually assign a material to them. in order to, better visualize your needs. Okay. Um, all right. So where did we leave? First, let's move on to our example from the Inclass. So uh, you might remember that we actually came across a problem when we were doing the loft. So here I have my base surface, the flat surface, planar surface, and then the offsetted wavy surface that was achieved by creating a distance field by using a curve. Okay, so in our case, I created a new curve over here, and then the curve is basically we are computing the distance from these points to this curve by using the curve closest point component. Okay, we're not interested in the points themselves. We are only interested in the distances. So we can actually turn off the previews for them. And I also added a second term for this, or the second component, to adjust the, let's say, the strength of this uh, movement or the offset. Okay, because by default, if you leave it at 1, you will get a result like this. The closest to the curve, the parts that are closest to the curve are almost like on the curve itself. Um, and the ones that are like going away, they are shifting quite fast. So you might not actually want that. So in that case, if you want to dampen the effect, you can actually like attach a number slider and multiply the distance values with that. Uh, the number sliders values should be between 0 and 1 if you want to scale down. If you want to dampen it, it should be some value between 0 and 1. Again, if you want high resolution, please don't forget to increase the digits of a real number. You can't use integer numbers in this case because it's going to give you full numbers. All right, so another thing is we are using the unit y vector. I didn't bother to flip this in this direction in order to not complicate things. But if you like you can always add a negative component to flip the direction like this. Okay. Um, all right. So I was talking about the loft surface having a problem, creating a problem. Let's switch back. Um, so the problem we came across is something like this. We essentially the loft surface asks for curves, and there is a shortcut in Grasshopper where if you have a surface, if you just hook them up directly into loft, it actually works by converting the surfaces into its boundary shapes. Okay. Um, this can also be achieved by adding a curve. Um, where is it? Somewhere around here. I don't know. Like honestly, I'm so used to using that method. Like there is a way to like get the wireframe of this surface. Perhaps it's in the surface. I don't know. So yeah. Anyway, it's probably wireframe. I'm not sure. Okay, this works for that. Yeah. Okay. Okay. So you can get the same idea with attaching your wireframe or directly hooking up the surface. Like here, this is our surface. This is a relay, which is the same thing. You can just hook it up, and then holding Shift on your keyboard, you can just add it. And this was the problem that we had come across, right? It's twisting because of the orientation of the curves or the way they are organized. Um, their seam locations, because their seam locations are different. The surfaces are all twisted. One common method to alleviate this problem is to add a loft options and turn on the adjust seams option, or set the value to true. In, again, most cases this works. However, in our case, in our very specific case, we had come across this problem where, the surface wasn't generated properly, especially during this corner. We expect this corner to be straight because it is straight, right? These 2 points actually are identical. So what we did or one possible solution to this is to change the seam locations for each curve that is generated from these surfaces, okay? So for that reason, we're going to use the same component actually, the curve closest point component. And what this will give us is, like, we need to use a point, obviously. So for that, I just created a point somewhere in, top corner of this top left corner of the front view. The reason for that is because, wherever you put this point, since it's going to find the closest point on these boundaries, um, they have to be like somewhat straight. And what I essentially want is I want to get rid of this kink. So I'm positioning it so that it actually generates um, 2 new points on the exact same corner, offset it at a distance. Okay. Now, of course, this is for this one. Uh, again, the points are not what we are looking for. What we are interested in is actually the parameter of this. So each curve will have a different parameter. So for example, for this one, actually the parameter being 0 indicates that this indeed is actually the starting point. However, for the second one, the newly generated surface, you can see that the parameter is some number like 46, okay? So that indicates that the starting point is somewhere else actually, rather than on the corner. So there is another component we can use under, where is it? Let's check. Right, under utilities, there is seam, okay? And as you can see, the components icon also indicates that it actually helps us to determine a new seam position. So for this, you get the same curve for both of them. I opted to duplicate these two, uh, rather than trying to like combine it into a merge or something. You can do that as well if you like, but like it's gonna introduce more complexity. So instead, I opted to just duplicate the component. And for the seam, you can see that it's actually asking for a parameter of the seam. We are actually using the component, the closest point component. So we have our new adjusted curves. So actually what we like to do is actually we would like to use these curves instead of directly from the surface. Okay, so for this one, I'm gonna hook up here. And then for the second one, I'm gonna hook up by holding Shift. Now, this didn't solve our problem. Well, it might happen. Uh, so let's try adjusting our points, okay? Let's try moving it in a better position. And also maybe like turn on adjust here. Yeah, okay. So by changing the seam position and also having this backup loft options adjust button. Actually, you know what? I think this is probably working wrongly. Okay, so since we adjusted the seam, actually it wants to get rid of it. That was the problem, I guess. Yeah. So you can try. Okay. If there's a problem with your surfaces, you can definitely add this portion. If you don't have a problem with that, in any of the variations that you're supposed to do, then don't add it. Okay, don't add unnecessary components. However, in our case, we actually needed these, so I'm keeping them. All right. So after this stage, we needed to add a okay. Need to add a brep join. Okay, and our surfaces are like this. This is the first one. The loft surface is the second one. I'm holding Shift on my keyboard to add this. And then finally holding Shift on the new surface. So if you see on the output of breps, if you see closed brep and also this closed output as set to true, then you're good to go. Okay. Then I can actually turn off the previews for these. So I don't need to see them. They are overlapping. Right now I have my closed brep. Okay. Right now I'm also going to turn off the preview for the curve. Okay, so we now have our surface. So at this stage we need to, like I said, we need to use contour. There are actually two different components. So two different sets of components and also like their previous versions in Grasshopper. You need to be using this one. It says create a set of brep or mesh contours. If you can't find it by double clicking and typing on this canvas, you can also go under curve tab, I believe. No, it's probably under surface. Mm, okay. No, it's under curve, however, under division. All right. This is, no. This is the curve version. Okay, I can't find it for some reason. Okay, let's type in and use this one. Where is it? Let's check. Ah, okay. So this is actually in intersection. All right. Um, so yeah, under intersect tab, mathematical, we have contour for brep to curve intersection. That's why we couldn't find it. So for this one, you can see that it actually asks for several inputs, and those that are needed as a basis is the shape. Shape is our object. And we also need to determine a distance here. The distance here is going to be like how far you want these contours to be created. Okay. So for that reason, I'm going to type in 50 on my keyboard. I'm not sure if it's the right size. So 50 is a little bit too much. Let's try reducing to 25. Okay, 25 seems kind of okay. We might need to shift this a little bit so that they don't actually like go at these corners, because adding stuff on the exact borders of the shape is actually not a good idea if you're working on a waffle structure. You may want to add some extra pieces so that it actually has a way to add those, or an alternative way is to just completely remove them from the list. That's also an option. So one direction is going to be this direction. So I'm not going to changing. I'm not changing this direction. The direction here is set to 001, meaning this is actually unit Z, right? Same thing. But we need another one, and we need that in the other direction. And that other direction in this instance is not going to be Z, but it's going to be unit X. Why? Because my surface is now oriented towards or along the x-axis, so we need to dissect this in the x direction. like that. Okay. So now I have basic contours. However, as you can tell, these are actually not creating anything. They are not um, creating any cuts. Let's again, for the sake of trying out, let's try the region slits component here. So region slits work like this. If you have closed shapes, such as these, you can actually combine those uh, like that, uh, and like enter some values for width and gap. Now width in this case refers to, let's say you have a shape like that. Width refers to this portion over here, and gap might be a little bit confusing at first. Gap actually isn't related to this or this size or this, for example. It actually is like, think of it as like this should be like 1/2 of the distance, right? So let's say if this is A and this is A, then the total distance should be like from this point to this point, the straight section should be 2A. So gap is essentially an addition, a slight addition into this, either, going forward or backward, in order to alleviate problems with tolerances. Okay, so for that reason, uh, yeah, you need to be aware of this. This is optional, by the way. Yeah, like you can just leave it as 0. However, we need to add a uh, slit width. So let's type. I don't know if 5 is gonna cut it, but let's see. All right, so let's disable these. Yeah, 5 is, okay. So here's 5 is actually enough. However, as you can see, we are now seeing Grasshopper's default behavior with data matching. Since our contours are in a grid format, we actually need to flatten them first. Okay, so I'm gonna flatten them over here all together. But the same thing happens. The thing that I mentioned before, when we bake them, you can see that some of the slits are open, some of them are not. They are all in the wrong directions. So I don't recommend this actually. Okay. So like if you're using this for like your own projects, I don't recommend using this method altogether. Instead, we're gonna build our own, uh, you know, region slits set of components, let's say. Okay. So what should we do? Well, actually, uh, let's have a look what's happening. So here you can see that actually these are not, these are just flattened portions of the things in order to like kind of like avoid this bundling of wires. I kind of like pulled it over here. They're not actually required. But what we need is, let's start building, first of all, some part. Um, we need to first of all find curve-to-curve intersections. Okay, so if I disable the final preview and start looking here, our first attempt will give us, I mean, these, can we see the curves? No. Um, the first curve-to-curve intersections are going to give these points. Okay, you might think these are the same points that we got um, from the grids. However, they are arranged in a different way, and as you can see, the list items are arranged in a not two-dimensional grid, but like in a kind of like a three-dimensional table sort of thing. Like we have 0, 0, 0, 1, and then it goes like 1, 0, 1, 1, and then finally 11, 7, and each of them also consists of 2 points. Those 2 points are the intersections, like from each curve. Okay, so what do? Is we basically separate those 2 points from each curve. Okay. Now you're right now. So what you're seeing is like they're kind of like on top of each other. But like if you separate them, and let's actually preview them with a point, you can see that the first set is like this, and the second set is kind of like this. So what we do is we are basically creating a line segment uh, from all of those locations. Okay. So what this will give us eventually is we're gonna like take the half size of this, like we are gonna essentially say from the middle, like create those slits in one direction, and for the other one, we're gonna do the opposite as well. But we need this orientation for this set of uh, set of plates. And uh, I think I mentioned this in class as well. Uh, the whole idea is to use offsets here. Okay, so we first started building out the curves like this, and then we are offsetting them in one direction. So let me show you the final result one more time. Yeah, so these are actually, as you can see, uh, the axis in which the slits are opened. So the width in the region slits component uh, can be obtained by using the offset curve. Now the offset curve component can be reached under uh, again I think utilities offset curve. We need a distance value, and because it's a parameter, when we make this into a cluster, it actually like gets it from the outside. Um, we need two instances of it actually, because offset curve works in one way by default, but if you add with merge a negative version of that same thing, it's going to offset in both directions. Okay, and then the other thing is you need to set a plane on which to offset this piece. Since these are our vertical elements, we are, and our, our wall is kind of like our furniture, let's say, is oriented towards or along the x-axis. We are using the YZ plane. YZ is this direction. So it's like, it's this plane. Okay. So that's why we need to hook it up. Otherwise, the default one, let me show you. If we don't do this, the default one is like this XY plane. As soon as I hook it up into plane, this is now working correctly. So without going too much further into this, let's apply these principles onto our own Inclass so that you can actually follow yourself. So like I said, we need to pick one direction. I think this was the other one. So let's start working on this one. Um, so what did we do? We used the curve to curve intersection method, right? For that, we need to use the intersect tab, and we need to check physical curve to curve. Now, uh, even though we are working on these, we need to utilize both of these pieces, okay? We can actually flatten them over here because they are singular objects anyway, right? So we have 11 curves over here for the lateral one, and 14, no, 15. 15 of them over here. We probably need to shift this, but let's see. If we come across a problem, we can always go back and change. Let's use it as it is and see what's going on. So one curve goes here, the other one goes over here. Again, because of data matching, if I hook it up like that, it won't work. However, as you know, there's a trick to working kind of like with these things. You can graft one of them so that it makes sure that the remaining curves or the remaining list gets matched to each single one of them. Okay, so these are 11 pieces, and these are 15 pieces, but like each one of them is like repeated. So the output gets converted into this. Okay, because the intersection is happening between two curves, the results are always the list is always like 2 points. That's why we needed to like separate this by not line, list item. Okay. And what we need to do, again, we need to do this zoom in thing where we actually like get the first element and the second element separately. The reason why we do that is we want to create a single line between them, and that is line 2 point like that. Okay. If you have trouble finding these, again, always please pay attention to the icons. Okay. So this goes here, this goes here, and let's hide these. Okay, so I think we're in the right direction right now. So our axes for the slits are now in order. Okay, so from this point, we needed to create an offset. Now, at this stage, there might be a different approach here. Like you can first find one section of it, or trim one part and then offset it. It's a matter of, approaching the problem in a different way. There is no right or wrong in this sense. If something is much more performant, I would advise you to choose the performant one. Uh, but yeah, so like I said, by default, it's like offsetting in one direction, and also it's now offsetting in the XY plane, which is not something we want. So first of all, we need to add a YZ plane to make sure that they are parallel to each other. And aside from that, we also need to provide a distance value with a slider. Okay, so for that reason, I'm going to add, say, 5. Now, look what happens if I hook it up. I can just move this, and everything is like kind of like shifting. However, we also need the opposite direction as well, right? Because we are going to use this axis to kind of like position the other objects that are going into it. So the trick is we are going to use negative. Negative is going to give us the negative version of this number. So if you hold shift and add it over here, it works like the both sides option in Rhino's offsets. Okay, it works identically. Now, of course, there are some problems. I'm noticing some problems, especially, like I said, the bottom and top part. So we probably need to go back and actually fix that issue before it becomes a problem. So notice that we didn't change this point uh, entry over here. Now the contour start point is actually, it determines, how far your surface is going to become. Surface is going to be cut together. So by changing the position of this point, you can actually determine where you want this to get started. Okay, so by default, it's in the origin, like so. But you can actually like play around with it. Now you can see that the X direction actually doesn't contribute at all. because it's again like it's not affecting the whole thing. And Y direction likewise also doesn't do anything really. The only thing, oops, okay. The only thing that this point affects is probably the Z height, right? So if you change the Z direction or the Z position, let's say, rather, then the contours will start uh, building from there on. Okay. Uh, Again, I don't want to overcomplicate things over here, so I'm gonna just eyeball this so that it doesn't actually like touch the top and bottom parts. Okay, let's check. So yeah, you can see that it now kind of like extends over here, which seems to me, in my mind, kind of okay. When we get to the other part, doing the slices on the other part, we're gonna probably add something like this again. So for the time being, since I'm done, I'm turning the preview of this. I also don't need to see this as well. All right, so at this point, let's save this and continue observing our cluster. So from this point on, we have two branches happen, actually three branches happening. We are using this output of the curve, the offset curve, in three different branches. Okay. Um, so we're not returning to the axis as a matter of fact. We're all using the same offset command. And how do we use it? Well, let's see. So remember that we have actually two uh, curves happening here. And I mean, because we use this negative distance thing, uh, our branching goes like 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, etc. So there's this 0, 1, 0, 1 at the end. That's too deep of a tree. Okay. Um, in in some parts, we need this kind of structure. Uh, for example, when I say start point, see what's happening here. Okay. So what I have here is I have a starting point and end point for each one of those branches. Okay. So let's suppose, I don't know which one is which, but like, let's suppose this is 0 and this is 1. This is 0 and this is 1. It goes on like that for every single branch throughout the grid. Okay. So if I hook up this endpoints component, what this will do is like it will give me uh, this point and this point, whichever is the starting end, the other one is the end point, etc. So then we need to do something else, however. So you can see that we get one point. However, this is again in this order 0, 1, 0, 1. Again, nothing is changing actually. As you can see, this is like both of them. But if I shift this, if I use shift paths, okay, this is different from shift, where is it? This is different from shift list. Shift path does the following effect. So actually, let's see the tree view for this. So our tree view looks like this over here. And after the shift paths, it looks like this on the other hand. As you can see, the number of branches is actually half. Um, the branch information goes into the list itself. So these 0, 1, 0, 1, 0, 1s are actually like, we're kind of like saying, don't do that. If you have these for each repeating elements, just convert them into a list. And that's actually what we are doing here by using shift. Okay. Um, we're not doing this before because it might actually like um, give us the wrong ordering for this kind of thing. So we actually need to repeat this like three times ahead. But eventually we need this kind of like two item list. So when I shift this, you can see that we are actually working on the back of this thing. And again, I'm dissecting it into two parts. By since we are now working with uh, lists that are containing two values, we need to again zoom in and add this +1 if we want to use it. Now we're not using it in this one, but however, uh, in the other direction, we're gonna. I think if I remember correctly, we're gonna use that. So we are basically getting the first index, and the first index, as you can see, is this one. Okay. In our case, this is like referring to the bottom corner. Um, and you can see that actually what we are doing here is actually we are computing the distance between 2 points. One over here and one over here. Now, how do we get this? Again, we need to find the midpoint of this curve. So from the same offset curve, we turn on point, midpoint. Again, this will give us two curves because, remember, we had two curves. So it's going to give us two curves. We're taking one, we're basically shifting them when we're taking one of them, and the one that is at the bottom is the first one. If I hook this up here, that's going to be the second one. Okay. So what we are doing here, I mean, you can get this ideally. You can just now that look at it, like it might be much easier to just get the distance value here and hook it up. But thinking in terms of these objects is always like beneficial. So um, this I think it would lost its meaning if this wasn't geometric and like uh, more like a numeric thing. This kind of thing I still find it useful for learning. Okay, so we are basically having this point, and we are computing the distance between them. Why is that important? Well, because in the next stage we're actually going to uh, trim our curve. Now, you might be confused because I talked about this before. Like I said, trim, but like actually there is no trim like component in Grasshopper. Like it's if you type trim, there are trim with regions, trim with breps, copy trim, blah blah blah. But none of these work as the Rhino's trim command. Okay, because Rhino's trim command allows you to select geometry and it will basically it's basically a magic tool where you can just do whatever you like. Um, Instead, what we have for curves is we have something called the extend curve. Now, Rhino also has extend. So how does it work? You might say, well, extend is in Rhino is extend is kind of like the opposite version of trim. In Grasshopper, they are actually kind of the same tool. Okay, extend and trim are kind of like extend is like you're extending the curve in some length, some certain length from the start point and or the end point. If you enter for example, a negative value, which as you can see, what we are doing over here is actually exactly like that. It trims. It trims that portion. So uh, let's unhook this temporarily, let's suppose 20. I'm hooking up over here. You can see that if I say 20, it's actually going to do something like this. 0 is the original state. If I say 20, it's actually going to add more. If I hook up a negative value, say like this, it actually starts doing the opposite thing. It's going to start trimming. This is actually what's happening underneath. Okay. So the reason, like I said, the distance here, actually, you know what? Now that I see it, I actually remember why I didn't use the distance, because this distance is actually changing. That's the reason, right? We don't know exactly what half of this means. The thickness changes because of the surfaces. If this was a box, we could have used the same distance, but in this case we can't. We need to actually compute this distance. That's why we need it actually. So, like I said, we're going to use extend to trim this. Now, there is one additional thing you might have noticed. There is a slight going off. Like for the start, for example, I added this uh, you know, one unit of extension over here. Okay. And the reason for that is because, like, if I don't do this, if I set it to 0, look what happens. You can see that since the offset curve doesn't, know if it's intersecting or not, uh, it might be a better practice to actually like extend this to some degree. Like even one might not cut it if you have too deep curvature changes and so on. So my recommendation here, just extend some more because we are going to eventually like cut it off later on. So just to like reiterate, we found the endpoints of the offset curve, the midpoint of the offset curve, and then we did a bunch of data wrangling to get the points, and in between the points we are computing the distance. We're trying to find what's the total length of that slit and what's the half length of that slit, etc. So before moving forward, let's get up to this stage in our in-class. So, all right, we don't actually need to see this anymore. Yeah, this is what we need. This is what I was talking about earlier about being short in high curvature changes. So, yeah, what do we do here? Right, we need to find the start endpoint and midpoint data. Let's observe if this is like if this works with shift data first uh, and then the remaining ones. Let's see. If it saves time, certainly we can. I mean, I'm suspecting we can't because like we are yeah, I don't think it will work because we need to actually get this one end of the curve. So we're not interested in the start part. So yeah, let's stick by the original devised version. So for the endpoints, we need to type in endpoints and add, as you can see, here's the result. So this is going to give us 2 sets of points. We're interested in this one only, this set. And the other one is we need midpoint. Now, midpoint, midpoint, curve middle, I'm sorry, curve middle. The shortcut is the output is midpoint. The component is called curve middle. Now, this is again, this can be obtained by evaluate curve. We saw evaluate curve in our previous lectures, but this is kind of a shortcut. Like this is essentially the same thing as like evaluating at 0.5 if it's a reparametrized curve. Okay, so we have the endpoints and we have the midpoints. You can see that these are pairs. So what we are interested in is we are actually interested in shortening these offset curves and then finally hooking them up and uh, converting them into a surface and then cutting it with curve Boolean. Okay, that's the whole idea. So yeah, I know it's a little bit convoluted, but you will quickly realize why we are like bothering in the first place. Okay, so I'm gonna delete the preview for this. So now we have to shift this because we want to get them into uh, list format. Okay, so shift paths. Now you see another one over here in my computer because this is actually a plugin that is found. What you will find by default in Grasshopper is this one, the purple one. Uh, in this case, it actually works. So I'm not like recommending that plugin just yet. Uh, the default offset value can be used because the default one is -1, which means like push the tree one branch back, meaning the last branch, turn the last branch into not a branch but a leaf object, which is a list in our case. So yeah, I'm going to use it like that. So combined with this, we need two list items as such. Okay. I mean, just for the sake, let's like, I think I added these because like I couldn't figure out which one to pick. That's why I also suggest you to like observe which one is which and try to understand the logic behind it. Okay, so for example, here's my first problem. Yeah, the orientation of these actually are wrong. So I'm suspecting this is because I did the the shifting thing on here, but like this reap probably shouldn't be here. Uh, so I need to get rid of that rip. So again, backtracking. So yeah, this is what I was talking about. We did solve the issue over here by shifting these. However, we didn't solve that. We didn't have the other end as well. So I'm gonna hook up another point and change this location of this point. Okay. So this in this case, since the direction is different, it's not it's now not going to respond in Z direction. It's not going to respond in the Y direction as well, but instead it's going to respond in whichever the unit vector is set to. It's going to respond in this direction, as you can see. So just to give us context, I'm going to turn on the other end as well. So this is actually what I was talking about earlier. We need to actually like do some balancing like so. If you don't do this, then the the points you see over here was actually like flipped. You see, the very end that is exactly on the surface was flipped. That's expected behavior, and you need to alleviate that problem by slightly shifting. I mean, again, from a manufacturing point of view as well, you don't uh, you don't immediately leave them at the ends because they're gonna be weak and they're gonna like come off easily. So at least leave some some pieces on both on either side. Again, I'm not exactly trying to measure or anything. You can just eyeball it if you like, as such. So now going back, yeah, we have this point and this point over here. Okay, so these 2 points are combined in uh, computing the distance. Does it really matter if I switch the other way around? It won't. Probably it won't, right? If I do it like this, it won't. However, you need to, like, you shouldn't mix them, okay? Because this is the incorrect. Uh, like if you compute the distance here, it's not gonna be half the size of this uh, axis, okay? So make sure that you don't mix and match. Just pick the right order. Yeah, so we need distance. We use distance today. It's actually used for computing the Euclidean distance between 2 points. And why do we need the distance? Well, we are going to use this component here called extend curve. The curve that we're going to extend is the curve itself. However, there is one thing you need to be aware. Before we use that curve, we are also shifting this as well. Okay? So if you don't do that, let's actually take this slightly off. We need this same here because otherwise uh, it's not going to work on list. Now, since this is a list of 2, if I hook it up like this, it's going to do a thing simultaneously. Now, the type can be left as line because this is a line, right? This is not an arc or spline. So I'm going to leave it as line. The start, again, I don't know which one is which. So we need to try. Like, let's try typing it, typing 2. And of course, we need to do this, let's say, for example, on the other end. So I'm suspecting, yeah, this is the wrong order, as you can see, right? Because probably it will work better if I shift these. Nope, not that, not doing well as well. Okay, let's see. We're gonna hide this. Hide. I'm gonna hide all of these. And then check. Okay, so start controls this side and controls the other side. Now we need to determine which end that we're gonna, make that slit joint. Let's suppose that we're gonna do this. Where should we do this actually? Yeah, we're doing this on the curved side. So in that case, we need to actually get this from um, it seems okay. One glaring mistake I made. I'm using the distance as it is. I told you that by default, if you want to trim the curve, you need to turn it into a negative value. That's why I'm having a problem. So if I turn it into the negative value, now I can see that it's actually doing its job. However, we probably need to shift this, say over here. Yeah. Okay, so when I shift this into negative values, now I actually get the centerpiece. Now for the extension, yeah, you can pick some number like 2. I think in this case there are no giant leaps uh, of curvature. So 2 is actually, I think, more than enough in our case. All right, so finally we need to do, when we have this, we need to combine the two ends uh, and Boolean the result. Now, in order to combine those, again, this is kind of a shortcut I came up with. Yeah, you can do manual work as well. Like you can find the endpoints and then join them and then join the curves all together. That's also going to work. But if if you can just loft these two curves, again, this is going to give you that surface, okay? That straight surface. And again, if you shift those, you can then use uh, the exact, uh, you know, uh, the rib planes and just do a curve or region difference curve Boolean. This is called curve Boolean in Rhino. In Grasshopper, it's called region. You can do the same trick that we did before. So if you have two sets of surfaces, it's going to get the boundaries of them eventually. So you can actually combine and get the clean, uh, uh, you know, get really clean, good results. Okay, so let's do that. Mm, I'm going to disable the preview for this one. I don't see it anymore. So this is what I was talking about earlier. Uh, Make sure that you have two curves here in each list. In this case, I have. So what this does is it actually creates these, you can think of them as sort of like strips protruding from each rib. And we also need, from our profile curves, a surface. So they are from here, as you can see. So again, the same trick. If I hook this up here, it's gonna, since this only works, by the way, this only works with plane curves. So it won't work with space curves. Please be aware of this. Since these are plane curves, I can just, yeah, take this. So we're using curves to create surfaces, and then we're going to use surfaces to create curves. That's kind of like this going back and kind of thing. Uh, it's always um, uh, an efficient way to handle this. So the command I was talking about earlier is called region difference. Okay. So region difference works exactly the same way Boolean does. So you have a uh, bigger piece, and then you're trying to subtract something. You do this A and B format. These are not interchangeable, so you can't just flip around. You need to uh, if you want to subtract the parts from some curve, it has to go A. The curves to subtract from goes to A, and the curves to subtract with goes to curves B. So I'm hooking up like that, and it's not working. Why? Well, because it's again the the same issue all over in Grasshopper, almost always the case, which is data matching, data matching, data matching. Okay, please be very very careful when you're doing this kind of work. So how do we solve this? Well, in this case, you need to observe the data structure. So for example, here I have 14 set of green surfaces. Okay. And coming from this, I have not 14, but 140 of them. Okay. So uh, since this is a grid, you know that these are uh, bound to be like arranged in one. So what I actually want, as you can tell, is let me draw it on the screen. So what I want, actually, this component or how this component to work is I want the subtractions to happen on one rib only. Okay, I'm not interested really in subtracting this one, say, from this curve, right? It's not going to work anyway, and it's unnecessary, computation. So how can I manage this? Well, uh, one thing you can do is like you can actually like uh, shift the paths of this loft tree, and then maybe like flip them and then match them. That might be one case. Now I don't know because this is not exactly the same one as this one. Let's actually try different alternatives and see what happens. But clearly, this doesn't work. It looks like it works. It doesn't give out an error or something, but don't assume just because it doesn't give out an error, please don't assume that it actually works in that case. Okay. Um, so yeah, let's try. So for example, let's try grafting this. So grafting in this case, as you can tell, doesn't work. I mean, again, it's actually kind of obvious why it doesn't work because this one is like now 14 branches. Let's also simplify it so that you can actually like compare. So these are 14 branches with one item each, and this one is 140 branches, being like the outmost branch is like 10 each for 13. So in this instance, for example, the way I handled this, I actually need again one shift path as well. Now this is the same idea, however, look what happens. Now it becomes like the 14 branch thing that I was mentioning. So now if I hook this up, let's check. There you go. We're seeing a preview here. Yeah, we're seeing the preview here. If I disable this, voila, I have my cut curves. Okay. Now, how does it work? Again, let's simplify it over here as well. So 14 branches, 10 items each. Is it right? Yes, because I want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items each. Okay, so um, we have uh, we have 10 items each and 14 items for the panels as well. Um, this is one side, okay? And actually, as you can tell, this is taking quite a lot. Now, um, I'm not going to bother, creating a cluster and then, duplicating it because it's still gonna, we still need to shift certain things. So what I'm going to do is I'm going to actually take the shortcut here and just make a copy of this over here. Now, please don't be fooled that this is going to exactly work the same way because it's not going to work the same way, okay? So let's go back and check the other end. Okay. So this looks almost identical, okay? And actually, as you can see, we are doing that shifting over here as well. Um, but there are some slight changes over here. Actually, did I? Yeah. this one is actually much simpler. The only, of course, simplification is because, the plane is actually, since it's lateral, it's XY. Uh, Other than that, it's more or less the same thing. The other thing also that is changing is the start and end positions of the extended curves because it's like flipping in other directions. Okay, like it has to be that way actually. So let's close this cluster. So yeah, start and end was like flipped on the other end. So no, let's move on. So yeah, the curves, the connections could be the same. Actually, we might simplify this later on since we are using more or less the same thing. We can actually like hook it up. The only thing that is important is like the these actually need to go away. So this will be replaced by xy, or you can leave it as it is, by the way, it doesn't matter. However, this doesn't work because, yeah, the curves should be also switching as well. So where is it going? So yeah, this one is going like this. One is going like this. Let's check. So now we are looking at here. Let me disable this over here. Now we have to check if the offset curves are correctly positioned. Yes, they are. And then, okay. So here's the thing that I was mentioning. The offset curve, sorry, the extend curve are in one direction, and they are the same position in the other one as well. So that's a problem, right? We need to therefore we need to switch the ordering of these. We need to hook it up over here and the other one over here. So that will actually flip the side on which these surfaces are created. Um, yeah, okay. So one final check. We need to check if our objects are, the strips are created correctly. It seems to be okay. Now finally, let's see. Need to disable this. No, there is a problem because this doesn't work, right? Okay, checking the data streams again. Okay, this is what I was talking about earlier. Uh, the the data scheme in this one is wrong because if we shift this like this, uh, it's actually getting 14 items from one side and the 10 items from the other side. So it has to be like, I think I'm suspecting if we, no, won't work. Um, okay, we have 14 items one side, which is the problem actually. Yes. Okay. So this wasn't the problem. Let's undo. Sorry for the backtracking. So the surface actually, because we copied this, surface is actually generated from the wrong one because these are the surfaces, remember? We actually need to hook this up for the other end. Okay. And let's check. Yeah, Actually, you know what? I think it works. Uh, let's compare between our other object and this one. Yeah, I think it's working correctly right now. Now, at this stage, like I said before, actually you have two sets of easily, fabricate, uh, you know, producible or like manufacturable sets of curves. Okay, you can take them to laser cutting. You can, take them to CNC milling. It's up to you. Um, however, for this assignment, we are asking you to generate technical drawings of these stuff. So to some extent, um, you need to convert them into 3D objects. Okay. Uh, for those who are like having trouble following up, let me just slowly, show how we started and how it panned out, and then we can move on further. Okay, so this is the part we actually get to start with the contouring, and then finally we are ended with two sets of curves. Okay, so for the final part, we're actually done with the cluster. We're getting into this section over here. Okay, so since we have two orientations, we need the unit x and the unit z vectors once again. Now this part is actually needed for the correctly placing the objects. However, the idea is like first before the correction, let me just first show you the simplest one. The simplest case is, let's suppose we have a cluster like this. I mean the set of curves like this. Um, we need to just extrude them, right? We need to extrude them in a certain direction, and that direction is unit x. And if you just cap them, you're done, right? However, like, if you don't do this, like if you just take this, if you don't do this transformation and if you just take this as a basis, you will see that they're actually kind of like shifting from the axis, the middle axis of this thing. That's actually what we're correcting here. This is actually the reason for this is because of a shortcoming in the extrusion command. Extrusion doesn't support bidirectional extrusion like in Rhino does. Okay. Um, so that's why we need to actually like do this kind of trick to like move it from one half size and then use that to extrude. Okay. So now you can see that you can see the you know this. Let me draw it a different color. So you can see the midsection right now. Okay. If you don't do this, then you will only like get in one direction, like it will offset in one direction, and it's not gonna be clear cut. So yeah, this is that correction. Let's do this. Um, so first, again, let me demonstrate what happens. So base. Which one was this? This is the Z direction. So it's like horizontal, you know? No, I was wrong. This is the vertical one. So X, right. Okay, so extrusion, cap holes is going to give us something. Um, the the thickness of course, should come from something. Okay, the thickness of the material is going to be a parameter in this case. And I mean, you can definitely like add a slider. And if they are the same material, if they are the same thickness, then you can use it all the way around. Okay. Um, let's do it for the other one as well. Yeah. So yeah, this is what I was talking about earlier. You can see that there's like a too much gap over here and like an overlap over on this side. That's why we need to do that fix I was talking about earlier. It's actually just a bunch of express like you can actually literally like write this as an expression as well. It's a matter of uh, style, really. Uh, since I'm teaching, I always try to be explicit, so I always use this kind of thing. So what we are doing is we're trying to get the one half of this vector as such, and then uh, turn it in the negative direction. This might not be needed. I'm not sure. We'll see. And then we're gonna say move. Okay. So the 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 object to move is the curve itself. Let's disable this because we're not going to use it anymore. So we are going to move these frames. We're going to move them in X direction, like so. So let's see. Yeah, I think this is the correct way. So now we're going to actually use the extrusion to get this. Okay. So this is the original, and as you can see, the extrusion is kind of like on both sides if you do it this way. Same deal. Uh, now, I mean, I think maybe like you can, let me try something here. Maybe in order to save, no, 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 we can't do that because we need to divide this. Yeah, we need to divide some value. Since we don't have that value, yeah, we need to say one half or something like one divided by 2 or something, and then add a multiplier term, which is essentially going to be more or less the same. And yeah, sometimes we can copy stuff, okay? Uh, so yeah, for the Z one as well, uh, the, the movement as well. The movement, however, the geometry is going to come from here. We're not going to use this anymore. The motion is over here, and the geometry is over there. So there you go. We have our uh, waffle structure, as a matter of fact. Now, uh, again, the display part is this kind of is optional. You don't need to do this. However, let me show you something about baking. Like we mentioned this earlier, uh, uh, but it's important that you organize your stuff properly. So you need to open again. Uh, First of all, you need to open a layer for your reference uh, geometry. Okay, by reference geometry, I mean if this is a wall or if this is a ceiling, you need to model these in Rhino with, of course, like we expect, um, proper sizes. So you need a layer for that. Okay, and then if you're referencing them directly from Rhino, then you need to like get that uh, by again using set one curve or set one surface, and get those inside. If you're having a brep, you need to basically use deconstruct brep to turn it into individual faces and so on. And then after that, once you're done with your setup in the Grasshopper file, you need to bake them into different variations. Remember that we ask you to actually get 10 of these. Okay. And please be very experimental with this. Like, don't bring the same thing over and over. Okay. So it's kind of like this. We should also write a script to generate these layers as well, which you can, by the way. Um, so yeah, we need to bake these. Let me show you one way to bake them into one layer. So once you have those layers, if you right click on the most, outermost part, by the way, we can actually turn these off. Previews, I mean. All right. So in order to bake them, you can just do stuff like this. Bake and then select the layer. You can group them if you like over here. Grouping again is not joining and it's not Boolean operations. Please be mindful about that. Grouping only allows you to move separate geometry all at once without like shifting and tilting. You can do it that way, or you can do the grouping inside Grasshopper. So you can actually take the object and actually also take the other one as well. Okay. And then like maybe like flatten the list. Then you can bake all together this one into one layer. Okay. So when I do that, let's hide these. You can see that now I have one variation listed under variations one. Let's change this color to something different. So this is in layer one now. Okay. If I disable this, I don't see it anymore. Let's try doing some changes to our model. Again, don't forget that you have a guiding curve of some sort, or it could be a point again, as I showed you. So for example, this also could be another layer. For example, this could be, I don't know, uh, surface manipulators or something. Okay. So please keep them in distinct separate layers so that we can actually like go back and change them. So what I'm gonna do is I'm gonna do a different thing over here. Like I'm gonna move this around and I don't know, like maybe change the positions here. If you want more exaggerated effects, you can undo the dampening part and put it like that. Okay. So let's also bake this. Now we're gonna bake this in variations too. So bake variations too. Since this is already a group, I don't need to select group. And we have variations too under the second set under variations too. Okay, let's change this to a different color. Let's say dark blue. So this was the earlier version, which by the way, I did no. Yeah, it's different, but like we need to hide this. This was the previous one. and this is the new one, and things like that. Okay. So please refer to the assignment sheet for details. Now, one thing that I just remembered, which was in the original script, but like I didn't go over. This is, again, I'm giving a disclaimer, this is optional stuff. It is adding a bunch of terms, as you can see, uh, which make things a little bit complicated, but like it's useful to know is like when you're working with this curve attractor thing, um, like here, this surface. Okay. Now, again, even if you dampen this by a multiplier, let me just disable this here. Okay. So even if you dampen this with a multiplier, it might still feel a little bit too, you know, too sharp around the corners and whatnot. Okay. So if that's the case, if you feel that way, again, since our topic is fields, there's an idea of smoothing of a field. Okay. So in this instance, we are actually using a much simpler approach by remember that each grid has a definitive value. You know, in our case, it's a distance value. So what we can do is like we can actually say, here's a list of numbers. Just run, uh, average the neighboring of each number, uh, average the numbers um neighbors, uh, you know, one before and one, next. Uh, and this will give us, this will kind of like avoid that immediate jumping thing that I mentioned earlier. Okay, so it's like it's a much more smoother change, and the way to do that in a list of numbers is this component called blur numbers. Okay, the problem with blur numbers is since we have a grid, we need to actually like kind of like flatten the list first, like this, and then revert it back to its original state. So the multiplication is still here, as you can see. So we only need to actually add these two terms along with the strength and whatnot. So let me finally add that, and we can actually wrap this up. Um, so, like I said, we're actually adding a term over here. Uh, Before the multiplier is done. All right. There was also a second curve, so I leave it as an exercise to you. I mean, here's a hint for you how to handle this. Uh, but that's an exercise for you. So how do we add a blur number? Well, instead of hooking up directly this distance value, we just say blur numbers, and we need to hook this up like that. However, we can't do it this way, and you can certainly, like you won't see much of a change, right? Uh, that's of course, dependent on the strength. Like you can adjust the strength and iterations, but also, so yeah, by default it's like set to 1. But also you need to, again, like since this is a full list, we need to give the full list in order to like average the numbers correctly. Uh, so I'm gonna flatten this list. However, when the averaging happens, okay, so these are the original values. These are the average values. I mean, they are not changing too much. Like for example, the second one actually changed. Um, we need to get the grid system back. So for this reason, we are going to use like flatten. There's also a component called unflatten. Okay, so unflattening. Uh, Unfortunately, there is no shortcut like this. Like flatten has a shortcut like this, but there is no unflatten because again, it's not just a shortcut. It's also like you need to say how like I'm gonna unflatten this one, but like how is the original structure is gonna come from? The original structures come from the original set. Okay, so the output is the numbers. It goes to 3. And the guide comes from distance because this was the original set. So what happens is this full list of 300 values turns back into this original structure like 20 to 15 grid. Okay, that's the whole idea. So now we can actually hook this up as if we are hooking up the distance. Now let me show you what happened actually in between. Push them. So let me just uh, hook the original one. The original one looked like this, and the smoothed version looks like this. You might say the other one was better. That's a matter of taste, of course. Uh, but it's clearly happening, right? It's kind of like getting rid of too much of an accented part. Like for example, in the original one, it was like this. Two sharp changes, uh, but as soon as we apply the smoothing, it's kind of like getting rid of those kinks. You can decrease the amount of smoothing or increase the amount of smoothing, or you can increase the number of iterations as well. The number of iterations now, as you can tell, is not just the multiplier. It's like getting rid of the kinks as well. Okay, so yeah, try different versions of this. Like I said, you're supposed to do like 10 different alternatives. So please make use of these aspects. Um, Notice what I'm doing here. When I'm trying out different alternatives for the surface, I'm actually disabling the whole script. Because if you keep doing it, like if you keep changing the slider and then each of these pieces are computed, it's probably going to crash at some point. Okay. Um, there are other alternatives to doing this, like there's a thing called data dam. There's a component called data dam, but like there's a much simpler way. Just disable one key component, and the remaining stuff will not be computed anyway. Okay, um, and then you can always like turn it on. Remember that enabling, disabling, and turning off preview on and off are completely two different things. So they are not the same at all. Be mindful of that. Okay. Okay. So let's suppose this is our third alternative. I'm gonna bake it as a final variation, and that's it. So thank you for listening. We'll see you next week. Bye.